as Mr. Salman just said, the title of this talk is an AI-enabled quasi-real-time water quality monitoring for early chemical or bio-contamination detection using Internet of Things. I will give a brief summary of the project and then we will discuss points one by one. This project is sponsored by TEIN and Asia Connect. I'll briefly introduce them and their activities. I will present the background of the project, what is the need for an AIoT-enabled water quality measurement and early forecasting system, especially in the context of developing countries that lie under Asia Connect region, like Pakistan, India, Bangladesh, and Malaysia. Then we will discuss how developing countries like Pakistan lack technological solutions to monitor water quality. I will discuss the activities of the project under the scope of this overall 1 year era. I will discuss the system architecture that we are aiming to develop by the end of this project, and the milestones will be discussed within. So what is TEIN and Asia Connect? TEIN stands for Trans-Eurasia Information Network. Basically, it is a European Commission co-funded project with the objectives, okay, to provide regional research and education network for Asia Pacific region, to connect researchers, academics, and students from these countries, and how? Via direct links to the pan-European network that is named GEON. One of the objectives is to connect users to their counterparts in Europe and the rest of the world. Okay. The countries that are member of TEIN are these, we are one of them, and our partner countries in this project are Bangladesh, Sri Lanka, and Malaysia. So what is the objective of forming TEIN body? It promotes digital inclusion in the Asia Pacific region, mostly in the developing countries. And it promotes regional cohesion. Why? To create more equal access to cutting edge network resources that most of the countries in the region do not have. And it acts as a catalyst for co-prosperity by stimulating the development of research networking in less advanced countries that are members here. Okay. What is Asia Connect? Asia Connect is basically a project initiated by TEIN in 2016. It was partly funded by European Union with a 20 million euros contribution, and the rest of the contribution is by Asian partners. And the project Asia Connect that has funded us is being managed by TEIN Cooperation Center, which is based in South Korea currently. Now, what about the project? The partners, as I said, are Bangladesh, Malaysia, Pakistan, and Sri Lanka. It is a short 12 months project. It started in March 2022, and it is expected to end in coming February. And the grant amount that we got for the system that I will explain in a while is 149,000 euros. The principal investigator of this project is Dr. Mohammed Wazan Faraz, he's right there. And the principal investigators are Dr. Arsalan Ahmed, sir, and so now finally we come to the background. What is the project about? What are the needs and what are we trying to solve by this project? One of the United Nations Sustainable Development Goals, number 6 specifically, is clean water and sanitation. Its vision is to provide a clean water and sanitation to maximum population of the world by 2030. And this project basically addresses SDGs 6.1, 6.3, and 6.6, which are safe water drinking for all, better water quality for aquatic life, animals, and humans as well, and healthier ecosystem. So, why are we addressing this SDG in this project? In Pakistan, only 20% of the population has access to clean drinking water. The rest of the population drinks contaminated water. Even the underground water that is used mostly is cleaner than the water that is acquired from open water bodies, but still it is contaminated with chemicals like arsenic. Okay. So as per a report, 60 million population in Pakistan is drinking arsenic contaminated water. That is highly dangerous. It causes cancer and respiratory diseases, and it can also kill people. Same is the case with our partner country, Bangladesh. 35 to 77 million people are at the risk of arsenic poisoning over there as well. So why an AIoT enabled monitoring system is required? This is a picture of Rawal Lake that was published in a newspaper back in 2017. I live not very far from this lake. It is a beautiful and big lake just at one corner of Islamabad. Every year, in the month of July or August, when the rains are not that frequent, a news out of nowhere appears on news channels that thousands of fish are dying, and probably someone has poisoned the water. Okay? In 2007, the water supply from Rawal Dam to Islamabad and Rawalpindi was discontinued for a period of 2 weeks due to this fear. Okay? Ultimately, it was detected the problem was not with any sort of poison initiated by any other sources, but the lack of oxygen in that water. Why? Due to lack of rain, the water volume decreased. All the fish that were alive in order to survive, they gathered in a smaller region. Ultimately, they started consuming more oxygen, so the dissolved oxygen level in the water reduced to a threat level, and they started dying. So if an IoT-enabled monitoring system was available, a lot of authorities could have been identified well in time, and they could have taken remedial actions to resolve this issue. This is another news from 2017. As per it, 91% of water supplied to Karachi, the biggest city of Pakistan with a population of around 16 million, is contaminated. So they don't have access to clean drinking water, which is, we can clearly see we don't seem to address the United Nations Sustainable Development Goal number 6. Another problem in Pakistan, as I said, 20% population has access to clean drinking water. Most of the population in rural areas, especially in the regions where underground water reservoirs are not that good, or poor regions where people cannot dig wells and have access to tube wells, they drink water from open water bodies. It is not uncommon to see water reservoirs where humans and animals are consuming water from that resource. So that water is highly contaminated, and one of the highest diseases that kill people in Pakistan are related to water consumption, diarrhea. Right now, Pakistan has been badly affected with floods. A few weeks ago, 1/3 of the country was underwater, and people who survived that flood somehow are now dying mostly due to contaminated water consumption. Another problem, the member countries, most of the member countries that lie under Asia Connect region, TAIN region, they are going to be severely impacted by water scarcity. So as per a report by Water Resources Institute, by the end of 2040, if I'm not mistaken, 2040, I think the colors are not clearly visible here. This region is of light orange color. The risk of water scarcity is 20 to 40%, and 40 to 80%. And then we have this region starting right from Pakistan, then Iran, up to Turkey, and in this region as well. These countries are going to be badly impacted by water scarcity. 80% of the underground wells are going to dry, and we won't have any access to clean water. We can already see that happening in Islamabad. People have to buy water, which is usually carried by tankers from 30 to 40 kilometers away. In a period of 4 to 5 years, as per estimates, those wells are going to dry up, and we have to do something very quickly. Another problem that motivated us for this project, I got this image from UNEP's website. They have been gathering data about water quality from the public-owned organizations who have already deployed remote sensing systems for a period of maybe more than 10 years. This is the water quality index of those countries. We can see in the region that lies under Asia Pacific, there is no data. Why? Because most of those water bodies are not even monitored. Pakistan Council of Research in Water Resources It carries out analysis yearly for major water bodies, but they don't have any IoT-based monitoring system. They conduct lab samples. They collect lab samples by visiting those lakes and water bodies, and usually they do so once or thrice a year. So they have their data sets publicly available. The problem is if you are collecting data thrice a year, and the water get contaminated by fertilizers brought by industries or by some other chemicals for the rest of 4 months before another test gets conducted, people will be drinking that contaminated water, and we won't be doing anything else. So they don't have any IoT-enabled monitoring system. So one of our aim is to develop such a system. And as all things are done manually on a period, after 3 or 4 months, timely contamination detection is not possible. So now, after discussing the problem, we come to the solution, what we are proposing. We propose to develop an AI-enabled, IoT-based, quasi-real-time water quality monitoring for early chemical and, I would say, or bio-contamination detection. What's the aim? The developed system is going to measure water quality remotely via IoT devices. It will forecast water contamination based on time series analysis. We are currently working with some RAs that are working with us, and we are applying and developing some ML and DL based algorithms for prediction. The system is going to forecast parameters measurable only via lab tests based on the proposed AI powered algorithms. You will see shortly some of the water quality parameters that I will discuss shortly. They can be measured by sensors, but there are some other parameters for which sensors are not currently available, or they cannot be measured by any sensor. So somehow the only way to measure that reading is to visit that water body, collect samples, and then conduct the samples in a lab environment. What we are trying to do, we have acquired data sets that were publicly available. Those data sets contain variables that are measurable by sensors, and it also contains lab sample results for various years, around 5 to 6 years. So what we are trying to do, we are trying to apply machine learning and DL-based algorithms to find correlation between various elements. For example, if the pH value and dissolved oxygen value increases to a certain level, does it somehow impact another variable that is not directly measurable? So if we can find that correlation, the system will generate alerts in time to inform the Pakistan Scientific Council for Water Research to visit that place and detect whether water is contaminated. So this is the overall system architecture that we plan on developing. I will quickly discuss this from bottom upwards. We start from the bottom layer. So we have water bodies, rivers, lakes, ponds all across Pakistan. First of all, we want to deploy an IoT-enabled system. Okay. For that, we are going to use we can use any of the microcontroller units, let's say Raspberry Pi. It is good if you want to do some on-spot analysis at the device. If you want to only acquire information by connecting sensors and send it remotely, then simple low-powered, low processing capability devices like Arduino Mega are sufficient for this purpose. They also consume less power. And we will deploy a series of sensors with any of these devices to acquire water quality parameters. Once those parameters are acquired at the device, they have to be somehow transmitted to the server that we are going to deploy and develop. So numerous wireless technologies can be used. I will briefly discuss them in a while. For example, data, if the server is nearby, which will not be the case in most of the applications, can be transmitted over Wi-Fi. For long-range communication, we can use LoRaWAN, which works in license-free spectrum and licensed spectrum. And for better quality of service, we can opt for something like LTE, M2M, or narrowband IoT. Now going upwards, so this is basically the deployment layer. This is the gateway layer to transfer the collected information. And then once data is received at our data center, we will have a storage layer over here, as we will be deploying such IoT system not at one location, but on many locations all across Pakistan. And the system, once developed, will be provided to the Asia Connect partners. So any of those partners can deploy their IoT devices in water bodies, and they can collect information on our system, do all sorts of analysis and prediction. So once the data is collected, it will be cleansed, and then we have the production and analytics layer, where basically AI-enabled algorithms will be applied to a forecast prediction. And once the forecasting is done, or whatever is being done, we have an application or presentation layer, where we will develop a dashboard on which we can see, let's say, parameters currently being collected for a particular selected water body. Or as this application is mainly going to be for government authorities and water management authorities, we will provide them a dashboard where they can see reports about all the sites on which IoT devices are deployed. So if any contamination is detected, or a system forecasts that a detection of such sort may happen in a system, they will be alerted immediately, so they can take remedial actions. And we will also develop a smartphone application. Basically, this is for technical engineers. Once they go to a site and they want to deploy a hardware, and they want to do necessary configurations in the dashboard. I want to deploy device X, which has ABC sort of sensors, and the communication technology is LoRaWAN. So that is what will be done. And ultimately, once all this system is developed, it will be deployed on the servers of our NERN and PERN partners. For example, in our case, Higher Education Commission's data center, so that all member countries can benefit from this system. So I will now summarize quickly. This was the overall idea of the project. Water quality parameters primarily can be classified into 3 different categories. We have physical water quality parameters like turbidity, okay, how much contents or solvents are there in water, temperature, its color, taste and odor, number of solids in water. They can be like sulfur, potassium, calcium, materials of any sort, and electrical conductivity. For example, pure water has pH value of 7, and it is almost non-conductor. Okay, so it conducts almost no electricity. So pure water, if you want to monitor its quality and it is not conducting any current, it is quite clean. And as the current starts to pass, the quantity increases. It means there are more minerals in the water that are acting as conductors. Then we have chemical parameters like pH value, chlorine, that does not exist in naturally in waters. Usually it is added to ponds and for cleanness. Dissolved oxygen, this is very important, and biological oxygen demand. As I said earlier, in Rawal Lake, every year fish die, not due to poisoning, but because of lack of dissolved oxygen. Water volume reduces. High temperature causes increase in contamination and distortion of that organic material, which results in increasing consumption of this oxygen. Also, at the same time, the amount of ammonia released due to that degradation and released by fish gills, it increases. Ultimately, that overall environment becomes contaminated even for the aquatic life in their time. Okay? So if they can die, we are definitely going to be infected if we consume that product. Quickly, I will summarize the activities of this project, because this is a work in progress. We will furnish the final report after 5 minutes. Work package 1, the overall project is organized into several work packages. This is overall project management, so I won't discuss this. Work package 2 focuses on training the trainer. Asia Connect has prime focus on training local people, so they can become skilled enough to develop such technologies. So this was the first task. I will discuss it briefly. Then the next work package is about development of AI-enabled early warning system for biocontamination risk propagation. WP4, development of a distributed information visualization framework for quasi-real-time water quality monitoring. And one of the last work packages we are seeing this activity is conducting workshop. So in the second work package, train the trainer, we were supposed to prepare training plan and content preparation for our team. We're supposed to do this in the first month that we have already accomplished. We trained our teams on water quality data harvesting from IoT devices. We also have embedded systems developers over here. And then we have very good research graduates from MS AI and MSDS programs, some UG students as well, who are working on this aspect. And ultimately, we plan on training some human resource on information visualization frameworks as well. We are waiting for a hardware to get delivered to us. Hopefully, in a month or so, we will complete this module in the next phase. Now, the main phase, development of AI-enabled early warning system for biocontamination, this propagation. I think you know the basics, so I will quickly skip through this. In order to measure water quality, okay, we need a set of hardware where we have plethora of options. We can go for relatively high-end devices, more powerful devices like Raspberry Pi, in case we want to do some on-spot analysis, which in most of the applications is not required. So I suggest going for relatively low power, low capability devices like Arduino Mega and connect sensors to that. I will quickly discuss the sensors available in the market and the set of communication technologies we have. And then ultimately, once this system is deployed, we can get measurements either periodically, if all is going well, on demand, if you want to check what is happening or not. So from a dashboard, a command can be passed remotely to a device to collect information. More importantly, this is the main focus, event-based. If a remote device detects a value that is out of range, min or max, it will not wait for the next period. It will immediately generate alerts so that any sort of contamination can be avoided. So these are basically the options that were available in the market. So we can either go for a ready-to-use system that already has a set of sensors connected to it, and we can collect information or Wi-Fi network and then deploy our own, let's say, GSM-based module, our own system to collect this information. We are not opting for this, but for partners who just want to deploy IoT monitoring system, I suggest using this sort of system. It is very easy to use and deploy, and it already has quite a lot of sensors connected to it. The best that we found in the literature was by Libelium. It has top-notch sensors, almost whatever can be sensed related to water quality. Those sensors are connected to this device. The only problem is it is way too expensive. The prices can go somewhere from 3,000 euros to 5,000 euros per unit. So some countries may not be able to purchase them and deploy hundreds or thousands of these devices. We can buy sensors separately for the market, whatever is required. And then we can choose an embedded system, a microcontroller unit, connect these sensors to it, and then get whatever readings you want. Personally, we are going for this option in this project. This is already discussed. Brief intro about the communication technologies. Time is short, so I'm skipping some slides. As devices will be deployed in water bodies, most of the cases they will be in remote regions. So we may need long-range communication technologies to collect data. So we have primarily two options over here. We can go for a non-3GPP standards or 3GPP standards. These, especially LoRa and SIGFOX, they operate in unlicensed spectrum, so you don't have to pay anything for the services. You have to pay only for the hardware. LoRaWAN offers a transmission range of 5 to 15 kilometers. In open spaces, it can easily get 15 kilometers. SIGFOX is a similar competitor. It offers longer transmission ranges as compared to LoRaWAN. So personally, in regions like Islamabad, if we are deploying multiple IoT devices on a lake site, I prefer to use something like LoRaWAN. Okay, so data can be collected. If deployments are in remote regions where visiting that site, collecting data is not possible, in those cases, long-range communication technologies like LTE-M or narrowband IoT should be used. They also offer higher quality of service. a quick overview of what we are trying to develop. This is the dashboard design that we have currently made. For example, a technical engineer from any Asia Connect country, we will provide access to them. If they want to deploy an IoT device at a certain site, we don't know which sensors they are using. So the system admin can add any sort of sensors in the system, their type, whatever units they have to measure, min, max units, something like that. Okay. And then once you have added this information, a technical engineer wants to go and deploy an IoT device on a lake site, for example. This is a view of the Rawal Dam in Islamabad. So the user will mention the device ID to recognize it, its description, where exactly it is deployed. We will Google pin, but also provide some textual description. And then once that device's details have been entered, we don't know which particular set of sensors are connected to that device. So the technical engineer will select all applicable sensors from this dashboard, do necessary configurations, select whichever communication module he or she is opting for, and this device then will be virtually added to the dashboard. Once the configuration is completed, it will start sending data to our server. So these are some mock-ups of which dashboard we are going to develop and provide to Asia Connect. Example, in this example, a user has selected a particular country and a particular lake site that is already being monitored. In our example, we are assuming Rawal Lake. So this is the dashboard that will be visible. So all the sensor readings that are being captured will be displayed. And if there are any alerts generated, they will also be displayed. They won't be displayed to common citizens. This is for citizens, anybody can view this data. Those alerts will be for the management authorities to avoid any sort of panic. Then comes the next and main part of the project, development of time series based AI model for real-time forecasting. So as I said earlier, some of the parameters can be acquired by sensors, and then there are some parameters that cannot be acquired by sensors. So lab tests have to be conducted. What we want to do, we want to find correlation between parameters, how, for example, temperature impacts pH level, which impacts the release of ammonia due to decomposition in water, decomposition of organic material and release of ammonia by fish gills, and how they are correlated. And then there are some, as I said, ammonia may not be measurable. So from a data set, we want to find the correlation between various parameters. And then even if that lab sample is not available, we want to somehow detect or predict in advance that if pH level is this, temperature is this, and that parameter is out of range, so parameter X may also be out of range. So this alert will be generated and sent to the authorities so that they can take actions. So we have 2 to 3 students who are working on proposing techniques for finding correlations and this is an example I found on the internet. The title of this paper was "The Often Overlooked Water Quality Parameters." The report was made by an oceanologist. So he is an expert and he already knows how various parameters are correlated. But if an IoT system is absent in a country and we don't have an expert, okay, there is no mean of finding out by fish per time. For example, in this article, he states that during peak daytime, especially in summers, the pH level of water increases. Due to increasing temperature, the decomposition level of organic material also increases. That results in increase of ammonia. Fish, they also release ammonia from their gills. Fish have a certain pH level of their in their blood. So if the pH level of pond water exceeds a certain threshold, already ammonia is being released by fish, and by that ecosystem, that ammonia is not going to kill that fish, the other aquatic life as well. So if we have systems that can understand such correlations and predict what needs to be done. These are some tests we are already conducting. We got a data set. We don't have data set now. So we got a data set of a Hong Kong river. It spans over, I think, 2 decades. But a comprehensive data set has been made available since 2015, where we can find data of variables that can be measurable by sensors, but also of variables that cannot be measured. Okay, so we are using this data set to somehow find correlation and predict from the other values how, for example, XYZ may impact A. Then ultimately, once the system is developed, it will be used for risk propagation through intelligent IoT devices. I think I have explained this quite in detail. The next part of this project we are currently working on it is development of a distributed information visualization framework that will provide comprehensive reports at different levels. For example, I'm working at a Rawal Lake site. I'm an employee of a particular organization. I can do reports related to contamination or forecasts over there. A regional level expert, for example, in Punjab province, who has access to hundreds of sites, he will have a dashboard to view whatever is the contamination or cleanliness level of water in different sites, so that he can take remedial actions. Then we will also develop a national level dashboard so that all the collected information can be intelligently used for some decision making. And as we are developing this system for Asia Connect, so this system will be provided to those countries as well. They can have all these features. Final outcome of the project that we plan on delivering by the end of February is this overall system that I just explained. So we are making good progress till now. Hopefully by the end of February, we will be able to deliver a very good system to the Asia Connect countries and our own countries' management authorities, so that we can avoid contamination. Thank you. Any questions, please? So.
Also an idea for you system. Maybe a drone, maybe a swimming body, because the number of sensors you need for all the water systems. Maybe it could be interesting to rethink mobile devices, mobile phones, or robots or whatever. From management, I think it's a whole thing, and they have really done a lot of things in this direction.
Thank you.
Because they are not so strong in communication, so maybe this could also be a homework.
Thank you. Any questions from the audience, online audience? Directly to cloud.
How much, what is the size of the data and how frequent is this?
Basically, we have scalar values reading of, let's say, temperature, what is the BOD level, TDS level. So we don't, the magnitude of data is not that big. So that is why I suggested using technologies like LoRa, WAN, and even SIGFOX that support very low data rates. So that should be even sufficient for us. We can have edge devices, but in our case, as the title mentions, quasi-real-time. water quality does not change in a split of a second. We don't need to make decisions. For example, as Sir was talking, we don't have a boat that is going to collide in 2 seconds. So we can take decisions after, let's say, 30 minutes or 15 minutes. That is why we are not going for edge devices. And the volume of data that is being generated and transmitted, it is not that much. So we can have deployments so far. Thank you.